Hi everyone, this is Cody at Lambda. In this video, I will cover different ways that you can run a Slurm job in a one-click cluster or private cloud and other products that Lambda may be offering in the future with a Slurm deployment. So if you're unfamiliar with Slurm or new to Slurm, Slurm is an open source workload manager used in HPC and ML environments. Slurm, an administrator, can create user accounts that have their access controlled. For example, certain user accounts may be limited to submitting jobs at a certain time or using a certain number of GPUs. And both administrators and users can keep track of their jobs, for example, if they're scheduled to run at a later time, or if those jobs can't be executed immediately due to resource constraints. So I will start off using the sbatch command to run a job on a Slurm cluster. So I will begin that by creating an sbatch script. So I'll create that script, just opening my text editor, and I'll name the script NVIDIA SMI batch.sh, and I'll paste in the contents of the script. Let me go ahead and just walk through what this script contains. First, we have the sbatch configuration that specifies 2 nodes and a total number of 2 GPUs. So that means 1 GPU of each of the 2 nodes. I'll be submitting 2 tasks, and 1 task will execute on each node. So a total of 2 tasks running on a total of 2 GPUs across a total of 2 nodes. The output from the command I'm running, which is NVIDIA SMI-L, the output of that command will go to the file that's under my cursor right here, and if there is any error from the command, it will be output to this file right here. I have set right here a wall time of 1 minute, and what a wall time is the maximum amount of time a job submitted to the Slurm cluster can run. So whether or not the job is complete, after 1 minute, the job will be terminated. These last 4 lines of the script show what is actually being executed on the Slurm cluster. So this first line simply prints the job ID of this submission to the Slurm cluster. Second line shows the nodes that the job is running on. And this final line is the command that's being run on each node. So just NVIDIA SMI-L. So I'll save that file and quit, and I'll submit the script to the Slurm cluster by running sbatch and then the file name. When you have longer running jobs, you can check the status of those jobs by using the squeue command. And I'll demonstrate this in greater detail a little bit later in this video. But because the job that I just ran is so short, it's not showing up by running the squeue command. So let's see the output created from that script. So I'll check out this file right here, which is the output. And as you saw earlier in the job submission script, we printed the job ID, so job ID of 90, and the nodes that the job ran on, so compute nodes 001 and 002, and of each of those nodes, a single GPU was used, and that's reflected right here. I'll show the output of the error file. And since everything executed successfully, I don't expect this file to have any contents. And that's what we see here. And then for this video, I'm just going to clean up these files so that we have a clean directory. I can delete the script file as well. And right now I'm going to show a longer running job. And specifically what this job is going to do is evaluate a large language model's ability to solve multiplication problems. So I'll download 2 files. The first file is the actual program that's going to be run. And the second file is the job submission script. So let's go ahead and check out what the program file contains. It's just a typical Python programs, and I've included in this program annotations so that you can better understand what's happening. But of course, if you want to learn more, just walk through every line of the code. So we're generating the problems here, and everything below here is for the evaluation of this large language model. But yeah, I'm not going to go through everything. If you want to take the time, you can go through it. And next, I'm going to be showing the actual script for submitting this program for execution on the Slurm cluster. So again, I've added annotations to better explain what's going on. I'll just quickly just go through this. We have the name of the job as well as the output files from the job. Again, we have 2 different files. Well, actually right here we have the output and any potential error messages going to a single file. So that's what we have right here. For the model that's going to be running in this program, or for this example, where you need 4 GPUs. And what we have right here again is the wall time. In a previous example, I set it to 1 minute, but here 40 minutes. So maximum runtime, and then this is how it's specified. I'll be using a single node, and on that node, a single task. Just right here, we're going to make sure that the model is specified when we're running this program. Right here is setting up the Python virtual environment, and finally running the script. So now I will submit this job to the Slurm cluster by running this command right here. And for this evaluation, using the DeepSeek R1 distilled Llama 70 billion parameter model. I'm hitting enter to submit it, and I have the submitted batch job 91. And earlier I showed the squeue command, but the queue was empty. But if I run it now, I can see the job that I just submitted. And if you remember, I specified the name as eval mul, and that's what we see right here. And for a little bit more information, I can run scontrol show jobs, and I can see the job is currently running. And this other job that was completed, this was just that very simple NVIDIA SMI example, which completed pretty much immediately. I can run tail-f eval results in order to see the output of the program that's being run. So this is just like a typical VLLM operation. We see right here that the model is loading, and again, just typical VLLM output. So in a couple of minutes, what we're going to see is the prompts being submitted or being run on the model, and then once this program is completely finished, we're going to see the accuracy of this model. Yeah, so what we see right here is the current progress is 0 out of the 1,000 prompts completed. So after a minute or so, the job will have entirely completed. All 1,000 prompts will have been processed. And then once that's done, I'll show the accuracy of this model. And then with this program, you can test various models and see the accuracies of the various models. But just for this example, I'm using the DeepSeek R1 distilled Llama 70 billion parameter model. So right now we're up to 83 out of 1,000 prompts. And just continue to wait. Okay, all the prompts have finished being processed. So I'm going to press Control-C to stop following the output. And I will run cat accuracies and the name of the model. And we see the accuracy of 0.6140. And I'm going to show that the job is completed by running scontrol show jobs. And right here, I see job state completed. And if I run squeue, there are currently no jobs pending. So that's the sbatch command. And next, I'm going to show the srun command, and I'm going to demonstrate it in two different ways. One is direct execution on the compute nodes, and the second is through a container. With Lambda's Slurm deployments, Pixis and enroute are pre-installed, which allows containers to be ran on the Slurm cluster right out of the box without additional configuration or the need to install any additional software. So with the srun command, in comparison to the sbatch command, srun has the job execute immediately or immediately upon resources becoming available. And with sbatch, the job is submitted to be run at a later time and doesn't require you to, for example, keep a terminal open. The sbatch command sends the job to the cluster for execution at a later time, which sometimes can be immediately if the resources are immediately available. So with this srun command, I'm specifying 2 GPUs, 2 nodes, and the number of tasks per node. So again, this means that 1 GPU will be used out of each of the 2 nodes. I'm outputting to this file the output produced by the NVIDIA SMI command, as well as prefacing the file with the node that the job is running on. So press enter to run this, and I have 2 files. I have this one that ends in compute 001, which is the GPU on compute node 001. And similarly, if I run, or if I check out the output of this file, the contents of this file, I see compute node 002 and the GPU that was used for the job on compute node 002. So that was direct execution. I'm going to just clean up some of these files here, the evaluation multiplication, the results, run eval. Okay, so now I'll show how to run those same commands, but this time in a container. So to do that, I'll be running this srun command, and all of this should be familiar. I explained it just a moment ago, specifying the output, but this time this output file will contain the word container, and I'll be using the NVIDIA CUDA image, and we'll be running the same commands as last time, but this time it will be with a container. So I'm pressing enter, and this one will take a little bit longer than the previous command because the image needs to be pulled from the repository. But it should not take very long. And the output files that will be created from this command will show that Pixis was used to execute these containers. And Pixis is just a Slurm module that allows containers to be executed in the Slurm cluster. So this is completed. It's going to list my files, and I see this first file that is compute node 001. And I see this first line that the Docker image NVIDIA CUDA was pulled from the repository. And pretty much the same on compute node 002. The image was pulled, and the output shows the GPU that was used for this srun command. So this covers srun. I'll just clean this up right here. And finally, I'll be showing the salloc command. And what the salloc command does is it allocates the resources that you request. It doesn't mean that these resources need to be used immediately or be used for a single job. So I'm going to run this to reserve resources, and with the resources that I'm reserving, I will be running bash, and what this will do is create an interactive shell on the compute node. If we look right here, currently I've been operating out of the login node, but once I run this command, I'm going to have a shell on the compute node so I can run commands directly on that compute node. So I'm hitting enter to run this command, and I see right here that I am on compute node 001. And because I have this shell on compute node 001, I can run NVIDIA SMI directly without having to preface it with srun, whether directly or in an sbatch script. So if I run NVIDIA SMI-L, I see 2 GPUs. And the reason why I see 2 GPUs, even though this node contains more than 2 GPU nodes, is because I've specified with the salloc command 2 GPUs on a single node. In order to exit this interactive shell, I can type exit and then hit enter. And once I run that, then those resources have been relinquished. So somebody else using the Slurm cluster will have those resources available to them. So this concludes the video. I've demonstrated 3 different ways that Slurm jobs can be run. Hopefully you learned something. All right, thank you for watching.